Okay, this is the third question in this section. This question's asked a wee bit differently. You'll see they've told you the voltage across the resistor being 120 volts. The voltage across the inductor is 90 volts. They've given you the resistance of the resistor at 80 ohms, nothing for the inductor, and they've told you the supply is 50 hertz, but they've not told you the value of the supply. So the first thing that's probably easiest to find out would be to sketch in a phasor diagram, and from the phasor diagram, determine the value of the voltage. So we'll sketch this over here. So this will be a phasor diagram. A phasor diagram should show you voltages and currents. We could only put voltages on it just now because we don't have a current to put on there. First thing, you've always got to look at these voltages and think to yourself, what scale would I use? So looking at these, I think my scale for my voltage, I think I'll say 1 centimetre would be equal to 20 volts. So looking at my VR, if 1 centimetre is 20 volts, then my VR should be 6 centimetres. So I'm going to draw that out to the side, 6 centimetres long. That's my VR. And again, going by that, if 1 centimetre is 20 volts, my VL will be 4.5 centimetres. So 4.5 centimetres. 4.5 times 20 gets you 90. That's my VL. Now, if I take a dotted line up from the end of my VR and a dotted line across from the end of my VL, I'll get the intersection it should just be on that line there, shouldn't it? 4.5. My intersection is there. So this third phasor that I draw in here, that's my supply voltage V. And going by my scale, when I measure this, I'm getting about 7.6 centimetres. So by measurement, my voltage is 7.6 centimetres, and using my scale, as 1 centimetre equals 20 volts, then 1 centimetre equals 20 volts, so 7.6 centimetres times 20 is 152. I can also get my angle for my circuit phase angle from this. Because my current, independent of length, will be in phase with my VR. So that's my angle in there. So by measurement, that angle using my protractor, we'll be counting up from here, 10, 20, 30, 5, 6, 7, 37. So that's it by measurement. I'm also going to do this by calculation. Your measurements will give you a guide, but your calculations will give you more accurate answers. So by calculation, I think, using Pythagoras, that my V will be equal to VR squared plus VL squared. So I'll take the square root of VR squared plus VL squared. Now to do this, because I'm going to put it in my calculation, I'm going to bracket this part here. So my VR is 120, my VL is 90. So in my calculator, square root, bracket, 120 squared plus 90 squared, close my bracket, equals. And that gets me 150 volts. Very similar to my measured answer over here. So I've got quite a lot of confidence that these two are fine. By calculation again to get my angle, my circuit phase angle, I'm just going to use tan. Tan of my angle equals my opposite over my adjacent. The length of my opposite is my VL. The length of my adjacent is this one here, VR. So my angle is going to be the inverse tan of VL, 90, divided by my VR, 120. And from my measurement, I'm expecting it to be round about 37 degrees. That's my expectation. So on my calculator, shift tan for inverse tan, 90 divided by 120. And there you go, I've got 36.87 degrees. So again, this angle is very similar to this angle. So I'm quite confident that that voltage is correct. Now the other thing, looking at my circuit diagram that I have, is when I look at this one component, I know the voltage across it's 120 and the resistance of it is 80 ohms. So I can find out the current through that one component. And because it's a series circuit, I know that if I can find out the current through one component, I've got the current through this component and I've got the supply current. So you can either work out the current for one component or for the whole circuit. So in this occasion, I'm going to work out the current for this component here. So I'm going to use the resistor. So using the resistance, I know that the voltage across my resistor is 120 volts. I know the value of my resistor is 80 ohms. So I can get the current through my resistor, which is the supply current, by doing I equals V over R. So 120 divided by 80. You can do that in your calculator if you want. 120 divided by 80. Be 3 over 2, 1.5. So that 1.5 amps is the current through this resistor, which is the current through here. No junctions, one current path. The current at any point in this circuit must be 1.5 amps. If I know that that's the supply current, 1.5 amps, I've got my supply voltage, 150 volts, I can now get my circuit impedance. So for my circuit impedance, as in the total, so my circuit impedance Z will be equal to V over I. So my voltage, that's my 150. My I, I've just worked out. It's been 1.5 amps. There it's there. So 150 divided by 1.5 gets you 100 ohms. And that's the value for your impedance. So that's the phasor addition of your R plus XL. So from this now, I'm going to use this to draw my impedance phasor diagram. I know that my circuit phase angle is going to stay the same. So I've got my direction for Z and I know what my value for R is. So now I have to pick a scale for my ohms. So 80 ohms. Looks like 1 centimetre equals 20 ohms. So because my R was 80 ohms, and I know that R always goes out to the right, that'll be 4 centimetres out to the right. That takes me up to that point there. That's my R. I don't know the size of my XL yet. I do know my circuit phase angle. I worked that out on this previous sheet. Worked that out here to be 36.87. So I'm going to do my best to mark out 36.87. I think it's about there. And I also know the value of my circuit impedance is 100 ohms, so that would be 5 centimetres. So going out from that origin, up to that point there, oops, that's 5 centimetres up to there. So that's my Z. And my angle in there is my 36.87. So now I'll draw in my kind of hatched lines that I've been using. And from my diagram, this line here, this would usually be my XL, which by measurement is 3 centimetres. So at that scale, by measurement, I think my XL should be 20, 40, 60 ohms. By calculation, I've got an angle, I've got an adjacent, and I've got a hypotenuse. So using my SOHCAHTOA, I'm going to use cosine, so I'm going to use cos. So cos of 36.87 equals my adjacent, R, over my hypotenuse, Z. And I could use this method as an alternative to get me the value for this Z here. So I've done it over here using this method, and I could use this method here to work out what it is alternatively. So my R I've got as being 80 divided by cos 36.87. And this should prove this. Cos. And that gets me my 100 ohms. So I'm quite confident that this answer is correct and this answer is correct. They both tie in. Now moving on to my XL, that's my opposite. So I'll just use tan again, as I've used previously. Tan of 36.87 equals my opposite, which is my XL, over my adjacent, which is my R. This time it's the XL I'm looking for and R is what I've got. So I'm going to move this R across to that other side and swap these two around. If your trigonometry is not that strong, this might be something that you want to go back and have a look at. So your R is your 80 times tan 36.87. and that gets me 60 ohms. And by measurement, I thought it was 60 ohms. So these two values, they now tie in with each other. So I've been able to pretty much prove everything. The only thing I haven't done at this point is marked in my 1.5 amps on my phasor diagram. So I have to choose a scale for it. I'll make it 1 centimetre equals half an amp. So I'll be 3 centimetres long. And that would be my I. So now every calculation has a diagram that proves it. That's your phasor diagram, your impedance phasor diagram, and all your calculations to back that up.